On April 6, 1945, 47 Soviet mortars opened fire on the fortress city of Königsberg. Each weapon hurled 246 kilogram shells into reinforced concrete embrasures that had shrugged off months of conventional siege fire. 72 hours later, General Otto Lasch surrendered 100,000 troops behind walls that took decades to build, brought down by a weapon so rare that only 47 of them were ever made. Concrete that cost millions of marks, forts that had defied every previous bombardment. Dismantled in 3 days by a mortar most armies had already written off as obsolete. The fortress problem had emerged from the catastrophic lessons of the First World War, when Russian siege practice exposed the inadequacy of conventional heavy artillery against reinforced concrete fortifications. Between 1914 and 1918, Russian forces used 280mm Schneider mortars and 305mm howitzers in various siege operations against Austro-Hungarian and Ottoman positions. But even these massive weapons required prolonged bombardments and enormous ammunition expenditure to achieve decisive results. Standard Soviet divisional artillery, including the 152mm gun family and 203mm howitzer class, often proved inadequate against reinforced concrete casemates when the objective demanded rapid neutralization rather than slow attrition. The Red Army possessed limited numbers of heavy siege pieces by the 1930s, systems that could not satisfy modern mobility or industrial supply standards. Soviet doctrine identified a critical capability gap between field artillery and immobile railway guns, requiring a mobile siege weapon that could be brought forward by artillery tractors emplaced within direct fire range of fortress walls and used to physically collapse reinforced concrete works within hours rather than days. The tactical problem came down to angle and mass. Reinforced concrete embrasures, armoured observation posts and buried command shelters could absorb prolonged fire from distant positions, but they remained vulnerable to close-range plunging fire from super-heavy mortars that could attack overhead cover and deliver massive explosive charges directly into structural weak points. Soviet artillery planners recognized that fortress reduction demanded not merely penetration of walls, but systematic destruction of firing systems, including embrasures, traverses, underground galleries and command posts, under concentrated high-explosive impact. The 152mm and 203mm systems, though powerful against field targets, often required excessive ammunition expenditure and time against thick, reinforced concrete objectives protected by earth cover or stone revetment. The operational requirement emerged from Soviet staff studies that treated the destruction of permanent fortifications as a distinct mission requiring specialized equipment. French, Belgian, Polish, and later German border fortifications represented the expected threat environment for future Red Army operations, and Soviet heavy artillery theory demanded weapons capable of reducing such systems fast enough to permit operational maneuver rather than prolonged siege warfare. The solution required a gun whose projectile mass could fracture reinforced concrete, whose explosive charge could destroy internal spaces and splinter casemate interiors, and whose carriage could be moved by artillery tractors over battlefield roads without railway dependence. Development of the Br-5 began in 1937, with the first order for 8 pieces placed in May, later reduced to 2, with formal development continuing through 1938, as Soviet artillery authorities commissioned the Br-5 plant in Stalingrad to develop a mobile super-heavy mortar for fortress reduction. The design brief arrived as part of the broader Soviet heavy artillery modernization program that sought to replace obsolescent Imperial Russian siege stocks with domestically produced tracked carriage pieces. Design supervision involved the Br-5 Artillery Bureau, which developed the tracked box trail carriage concept alongside the 152mm Br-2 gun and 203mm B-4 howitzer. The Br-5 team reached for standardization across the super heavy artillery family, designing the Br-5 to share the same tracked mounting system that had proven successful with the lighter pieces. The carriage could distribute recoil forces across a broader base than wheeled systems, improve stability on soft ground, and permit tactical repositioning without complete disassembly. The engineering trade-off was clear: battlefield mobility at the cost of strategic speed, with longer road moves requiring the barrel to be detached and transported separately on the special Br-10 wheeled carriage. The weapon entered service in 1939 as the 280mm mortar M1939, designated Br-5 in the Soviet nomenclature system. But this was the part Soviet planners worried about most. A weapon this expensive, this slow to move, this specialized, would have to justify itself against an actual fortress, or the program was dead. The siege monster that emerged from Br-5 combined massive destructive power with deliberate, methodical employment doctrine. The Br-5 weighed 18,400 kilograms in combat configuration, rising to 19,900 kilograms in transport order, making it among the heaviest standard field artillery pieces used by the Red Army during the Second World War. The weapon measured approximately 4,750 millimeters overall in firing configuration, with a barrel length of 3,975 millimeters, representing 14.2 calibers of relatively short tube length that classified the system as a mortar rather than a conventional gun. The bore diameter measured precisely 279.4 millimeters, and the complete system required substantial crew for emplacement, ammunition handling, loading, and traverse operations. The ammunition system reflected the weapon's siege artillery role through separate loading components rather than fixed cartridge cases. The standard high-explosive projectile weighed 246 kilograms, with a TNT-based bursting charge and nose fuse designed for either instantaneous or delayed action, depending on target type. Against concrete works and embrasures, delayed action drove the shell into the structure before detonation, while instantaneous action produced stronger surface blast and fragmentation against personnel and exposed material targets. The muzzle velocity of 356 meters per second generated a maximum range of 10,410 meters, modest figures that reflected the weapon's close-range siege mission rather than long-distance bombardment capability. The separate loading system used variable bag charges rather than brass cartridge cases, with projectile and propellant handled as distinct components by the ammunition party. Each round demanded coordinated manual labor around the breech and along the ammunition line, with multiple crew members required to lift, position, and feed the massive shell into the barrel. The loading sequence was labor-intensive by design, trading rate of fire for destructive effect. Experienced crews managed approximately one round every 4 minutes under normal conditions, with sustained fire limited by shell handling geometry and the need for careful laying after each shot, due to recoil and blast effects. And that loading rate is the detail that would matter most at Konigsberg. 15 heavy shells per gun per hour, against a city defended by 100,000 men. The tracked box trail carriage provided the structural foundation for absorbing recoil from such a large projectile, but it also imposed significant mobility constraints. The weapon could traverse and reposition over short distances on its tracks, but longer moves required disassembly into major components. The barrel separated from the carriage and traveled on the Br-10 wheeled transport for road movement, while the tracked chassis moved independently. This modular arrangement reflected Soviet priorities: maximize destructive force in a weapon that could still be brought into the zone of operations by artillery tractors, then emplaced as a deliberate siege piece close enough to destroy bunkers and forts with precision heavy fire. Soviet doctrine deployed the Br-5 in special power artillery brigades at front level, rather than distributing the weapons to divisional artillery regiments. The employment philosophy emphasized concentration of super-heavy assets under centralized control, with individual batteries assigned to specific fortress complexes or bunker groups based on intelligence preparation and target analysis. The weapon's characteristics dictated its tactical use: slow rate of fire but immense destructive effect, modest range but devastating accuracy against fixed works, and deliberate emplacement in prepared positions rather than rapid tactical movement. The crew reflected the manual labor-intensive nature of every aspect of Br-5 operations. The detachment included specialists for loading the separate projectile and propellant, operating the breech mechanism, sighting and laying the weapon, managing recoil and carriage functions, and handling ammunition supply from the battery trains. Additional personnel beyond the gun's immediate crew supported emplacement, ammunition movement, and engineering tasks necessary for preparing firing positions. The weapon demanded not simply gunners, but a combined artillery engineer effort that could emplace the mortar, register targets, and sustain deliberate fire missions against reinforced objectives. The doctrine called for close-range emplacement against individual forts and bunkers, with firing positions selected to permit repeated engagement of the same strongpoint until its defensive capability was eliminated. Soviet artillery manuals treated super-heavy mortar fire as a demolition instrument used in coordination with assault infantry and engineer units to transform fortress positions from fighting works into penetrable ruins. The Br-5 succeeded not through rapid suppression, but through systematic destruction that made organized defense extremely difficult. If you want to see exactly how those 47 mortars broke 100,000 defenders in 72 hours, the assault is next. Subscribe before it starts so you do not miss the rest of this series on the weapons that quietly decided the Eastern Front. April 6, 1945, marked the opening of the final Soviet assault on Königsberg after months of siege and preparation. The Third Belarusian Front under Marshal Alexander Vasilevsky concentrated massive artillery forces against the fortress city, including super-heavy mortars, heavy howitzers, and siege guns drawn from front-level artillery reserves. Königsberg's defensive system consisted of 19th-century forts, modernized with reinforced concrete and integrated into a distributed belt surrounding the city, defended by approximately 100,000 German troops under General Otto Lasch. The Br-5 mortars operated as part of special power artillery units attached directly to front headquarters rather than subordinate formations. Soviet artillery doctrine for fortress reduction emphasized the concentration of the heaviest available weapons against individual strongpoints, with super-heavy mortars assigned to engage specific forts, bunker clusters, and command posts that resisted conventional divisional artillery. The weapons were emplaced in prepared positions within direct fire range of their targets, often in concealed or masked locations that protected the crews from German counter-battery fire, while permitting precise registration on fortress embrasures and observation points. The bombardment began at dawn on April 6, with a sustained artillery preparation that continued for several hours before the infantry assault commenced. Soviet reports claimed that super-heavy mortars smashed embrasures and severely disrupted counterfire across multiple fort complexes. The 246-kilogram high-explosive projectiles delivered at close range produced effects that conventional artillery could not easily achieve: destruction of firing slits, collapse of interior spaces, and neutralization of German artillery positions that had resisted previous bombardment. Individual forts became focal points for Br-5 employment during the assault, with Soviet mortar batteries assigned to engage the fort's embrasures, command posts, and artillery positions through deliberate registered fire missions. The fortress structures, built of 19th-century masonry and strengthened with 20th-century reinforced concrete, suffered severe damage under the concentrated impact of multiple heavy shells delivered with precision targeting. German defenders found that the fort's interior spaces were heavily damaged, with structural collapse making organized resistance extremely difficult. German gun crews abandoned their firing positions under super-heavy mortar fire. Embrasures were smashed and observation posts destroyed faster than they could be repaired or replaced. Counter-battery fire became sporadic and ineffective, as German guns were forced to give up fixed positions and try firing from concealed alternate locations. The systematic destruction of fortress geometry itself eliminated the German defensive advantage that had sustained resistance through the winter siege. By April 9th, after intensive bombardment and assault, General Otto Lasch ordered the surrender of the Königsberg garrison. The fortress city that had withstood months of conventional siege warfare collapsed within 4 days once super-heavy artillery achieved decisive concentration against its defensive works. Soviet after-action reports credited the Br-5 and other super-heavy weapons with breaking the fortress system through systematic destruction of embrasures, command posts, and artillery positions that formed the backbone of German resistance. But the Germans still had one card left, and they played it badly. German adaptation under super-heavy mortar fire revealed the challenges of traditional fortress defense against modern siege artillery. As Soviet Br-5 batteries achieved registration on individual forts and began systematic destruction of embrasures and firing positions, German defenders were forced to relocate command posts to deeper underground shelters and abandon exposed observation points that had become death traps under concentrated bombardment. Artillery crews shifted from sustained counter-battery fire to intermittent concealed engagements from alternate positions, trying to avoid detection and immediate destruction by Soviet mortar batteries. The German response was emergency improvisation. Fort commanders ordered the abandonment of compromised embrasures and the relocation of artillery to masked firing positions. But these improvisations could not restore the systematic fire control that fortress defense required. German batteries attempted to use dummy positions and brief exposure firing, withdrawing into cover immediately after mission completion. But the overwhelming concentration of Soviet heavy artillery made even these tactics increasingly futile. Concrete reinforcement could not be improved during the battle itself, leaving German defenders dependent on existing 19th-century masonry strengthened with early 20th-century concrete that proved inadequate against close-range super-heavy mortar fire. The fortress system's geometric advantages dissolved as embrasures were systematically destroyed and interior spaces collapsed under repeated heavy shell impacts. German doctrine called for relocation to deeper battle posts and the use of alternate firing positions, but these measures preserved personnel without restoring defensive firepower. The most concrete German adaptation was the reduction in observable counter-battery activity as artillery crews learned to avoid sustained firing from identifiable positions. Soviet reports noted that German counterfire became sporadic and ineffective, reflecting the enemy's inability to maintain organized artillery support once the fortress firing system had been systematically dismantled. German forces withdrew from outer defensive positions into interior strongpoints and cellars, fighting from ruins rather than intact fortifications. But this sacrificed battlefield initiative without offering any path back to organized defense. The economic arithmetic of the Br-5 program revealed the weapon's role as a specialized industrial product rather than a mass standardization item. Br-5 plant in Stalingrad produced only 47 Br-5 mortars total, making it one of the rarest weapons in the Soviet arsenal. The limited production run reflected the weapon's very high machine tool burden, extensive precision machining requirements, and the specialized tooling needed for the tracked carriage family, shared with the Br-2 and B4 systems. Each Br-5 was a substantial investment in industrial capacity: large steel forgings for the barrel, complex recoil mechanisms, precision boring and rifling, hand-fitting of the tracked carriage components. The shared carriage architecture with the Br-2 gun and B4 howitzer amortized some development and tooling costs across multiple calibers, but the overall weapon system remained extremely expensive in both materials and manufacturing time. Soviet industrial planners treated super-heavy artillery as a machine shop-intensive product requiring specialized facilities rather than a line production item suitable for mass manufacture. The contrast with German fortress construction economics showed the asymmetric relationship between offense and defense in siege warfare. Königsberg's fort system represented decades of construction investment, millions of marks in concrete and steel, and thousands of man-hours in engineering and fortification work. The 47 Br-5 mortars, despite their limited numbers and high individual cost, proved capable of systematically dismantling fortress works that had required far greater industrial investment to construct. The weapon's value lay not in production efficiency, but in its ability to concentrate destructive force against targets that conventional artillery could not defeat economically. The industrial reality also explained the weapon's tactical employment doctrine. With only 47 pieces available across the entire Red Army, the Br-5 could not be distributed to routine artillery formations or used for general fire support missions. Instead, Soviet doctrine concentrated the available weapons at front level for specific siege operations, where their unique capabilities justified the logistical burden and ammunition expenditure. Each Br-5 represented a strategic asset rather than a tactical tool, reserved for operations where fortress reduction was the decisive requirement. The production numbers also reflected Soviet industrial priorities in the immediate pre-war period. The Br-5 plant's capacity was divided among multiple heavy artillery projects, with the Br-5 competing for manufacturing resources against the more numerous Br-2 and B-4 systems that offered broader battlefield utility. The decision to limit Br-5 production to 47 pieces demonstrated Soviet recognition that super-heavy siege mortars addressed a narrow but critical capability gap rather than a general artillery requirement. The weapon remained in Soviet inventory for decades after the war, long after its siege artillery mission had been superseded by tactical air power, improved medium artillery, and self-propelled gun systems that offered greater mobility and battlefield flexibility. Soviet practice preserved large-caliber legacy artillery in reserve storage for extended periods, treating the weapons as potential assets for special operations rather than frontline equipment. The weapon's post-war survival reflected its durability and the conservative nature of Soviet artillery doctrine, which retained proven systems even after their primary mission had evolved. Museum collections and commemorative displays preserve surviving Br-5 examples as artifacts of siege warfare, with the tracked carriage and massive barrel serving as physical reminders of an era when fortress reduction required specialized super-heavy weapons brought forward by artillery tractors and emplaced in prepared positions within direct fire range of reinforced concrete targets. The Br-5's true legacy lay not in its limited production numbers or post-war service, but in its demonstration that mobile siege artillery could break modern fortifications when properly concentrated and employed. The weapon proved that tracked carriage systems could deliver strategic-level destructive power at tactical distances, enabling breakthrough operations that would otherwise require prolonged siege warfare or massive ammunition expenditure by conventional artillery. Soviet heavy artillery doctrine absorbed these lessons into post-war planning, emphasizing the value of specialized weapons for specific missions rather than relying solely on general-purpose systems. The tracked carriage concept, pioneered by the Br-2, B-4, and Br-5 family, influenced Cold War Soviet artillery development, particularly in the design of self-propelled heavy guns and nuclear-capable systems that required exceptional mobility combined with massive firepower. The engineering principles validated by the Br-5, including modular transport, precision emplacement, and deliberate fire missions against hardened targets, continued to shape Soviet artillery thinking through successive generations of weapons development. No known export use is documented for the Br-5, emphasizing its status as a Soviet internal asset rather than a diplomatic or military aid instrument. The weapon's specialized nature, limited production, and siege-specific mission made it unsuitable for transfer to Allied forces or client states that lacked the industrial infrastructure and tactical doctrine necessary for effective employment. Foreign military observers studied the weapon's effects at Königsberg and other siege operations, but the Br-5 itself remained exclusively Soviet equipment throughout its service life. The 280mm mortar M1939 proves that battlefield results do not track production numbers. 47 weapons, each requiring extraordinary industrial investment and substantial crews, achieved decisive battlefield results that altered the course of fortress warfare in the final months of World War II. Konigsberg's embrasures, which had absorbed months of conventional fire, came apart in 72 hours. 47 mortars, 100,000 defenders, 3 days, that was the math that ended Königsberg, and it is the math that explains why specialized siege weapons sometimes matter more than mass production ever could. If that breakdown landed for you, the rest of the weapons that quietly decided the Eastern Front are already waiting on this channel. Subscribe and start with the next one.